Hey everybody, this is Michael, and this is my project for this course for CO2 6931. The name of my project is called Simple Database Package for Sociology. The acronym is SDPS. Now, the background of this project started when I was a student for sociology. When I was a student for sociology, many sociological departments would often use specific methods such as quantitative methods or qualitative methods, but some departments did not use new technological innovations such as databases because due to a lack of familiarity with the actual technology. So although sociology is a discipline and has developed various research methods, and it's developed statistics, surveying, it's developed interviewing and ethnographic methods, it has not used new technological innovation in a more widespread manner. In fact, many sociologists have never had the opportunity to use the technology for either research or leisure purposes. So in my opinion, this lost opportunity is a gap within the current array of research methods that are being utilized for sociology. And so that's the main purpose of my software program, to be used to fill in this gap, to give an opportunity for undergraduates, for example, to use this technology that they otherwise may not use at all or even consider using. Now, part of the background, part of filling this gap, what my project is doing is following a long tradition of sociologists developing their own methods to answer a research question. From Emil Durkheim, who was a sociologist during the late 19th century, 1895, he created a methodology called social facts as a mechanism that structured sociological methodology towards positivism, to as recent as Barney Glaser and Ansel Strass developing grounded theory for qualitative methods through the 1980s. Sociologists have had a long tradition of making their own methods. Now, sometimes methods can be made outside the discipline, and other entities have developed research methods for sociology through technological innovations, such as IBM creating the statistical package for the social science, otherwise known as SPSS, or software engineers creating a web crawler that collects copious amounts of data from the World Wide Web for analysis purposes. Now over here is an image of SPSS, and you can see that it's very similar to what a database query table results would look like. You have the ID column, which serves as the unique data that identifies the other information within the actual data set. The problem, though, with SPSS is that SPSS is considered to be highly complicated for someone who's just starting out, that there's a lot of functions and buttons. Plus, the main purpose of SPSS is to use the data sets to create mathematical formulations in order to find some kind of connection. For example, SPSS is often used for regression analysis or correlation, and these mathematical techniques are used to answer research questions for big quantitative projects, I mean to say. And then, of course, a web crawler does something not similar to this, but rather it collects large informations from the websites, and people use this to analyze things, like perhaps what websites we go on. Now, both of these are new technological innovations that sociologists use. However, they're highly technical. And the main purpose of my contribution, my SDPS, the main purpose is to create something very simple, something very easy to use, and something that can be used every day, and something that can actually teach students the very basics of SQL. Now, this is a proposed interface that I'm going to make for my Sdps. And my Sdps will simply take the name of a database, the password, and then it will connect to a MySQL workbench, and then it will dynamically produce table names, and then within each table will be several column names, and by selecting all, you can join the tables or you can just choose individually. And you can even set the conditions such as and, or, order by statements. You can even do inner, left, right, and full joins. And while doing all this, the SQL query below will dynamically represent the selection that was chosen in these two boxes above. And the reason I do this is because I really want students to learn. I want them to be able to understand what does a SQL query look like. And then this button, Generate Table Results, will create a table below, and this is of course just a sample. This is a scroll panel, and obviously a scroll panel will be here if the table is too large. I want to have the main interface, all these buttons used primarily on one page. And then of course there's a reset button and an exit button. A reset button would allow someone to change the database that they're using plus change the password so that they can access a different database through MySQL Workbench. And then exit simply terminates the program, ends the program. Now, while I do not have a research question at the moment that I want to answer, my goal is to develop a method that in hopes that a sociology student, researcher, or teacher who may one day have the appropriate research question in which they can use my method as a way to answer it. The method that I want to deploy is called the Sdps, a potential user-friendly interface for sociology students, teachers, or researchers that do simple, read-only actions with a database, such as generating a table of results based on SQL, structured query language, as shown here. And then the purpose is to use this table to extract it for sociological analysis. Now, how I'm going to make this project? Well, first I need to create a work schedule. And right here is my current work schedule. And you can see that I've already had 6 deliverables due for this semester. I'd like to indicate that I'm actually a first semester student. So next semester I will actually be working on creating the actual interface. And the interface will eventually be an executable program that users can use anytime as long as they download it. And you can see my schedule that I plan to create the GUI part first, then implement the functionality of the program, the buttons, and then test the functionality. And then after the testing is complete, create a user manual to help people go through the basics of using the actual Sdps. Now my management has a process, and the process that I'm going to use is the spiral method. And each dot that you see here is a different milestone that I need to pass in order to reach the end, to complete this project. Now, this first milestone, this first green dot and this first blue dot, they're connected. The green dot represents the code, and the blue dot represents the test. And when they pass this line, then we enter a new iteration of coding, and when they pass the blue line, we enter a new iteration of testing. Now the first one will be build the interface with all the required buttons without any functionality. Then the second milestone will be create the backend functionality for each button and wire them accordingly. Then third will be create a login interface that connects to a localized database, as well as create an exit button that ends the program and a reset button that allows the user to change from a database to another. And finally, the fourth milestone which will be here, is create another interface that will start the program, as well as transforming the software into an executable file. Now, here are my requirements that I need to follow through. The purpose of this program is to design a simple interface that easily interacts with the database. This program will produce stimulus through the button functions to create a specific response based on the button's name. The required functions for the array of buttons are the following: a button that allows the user to select a given table's columns, a button that allows the user to set conditions on their query, a button that generates table results, a button that allows users to change databases, a button that starts the program, and a button that ends the program. The file must also be executable and user-friendly, especially to users with no SQL training. In other words, this program is going to be as simple as it possibly can. Simple enough where one can do simple read-only actions, and they don't need much SQL training in order to use this program. At the same time, this program will also give the ability to learn the basic fundamentals of SQL, and it will also be accessed every day. Then, of course, this is my UML design. To go over it very quickly, I'm going to have a start program GUI that will generate the login GUI. And in the login GUI, we'll use a class called Connect with SQL, which this will allow us to connect to the database after someone has inputted the database name and password into the login GUI. And when this is successful, then the login GUI will create the user interface GUI. And the user interface GUI is an aggregation of other classes. And I say aggregation because suppose it didn't have the exit program, it still can function with database columns, read queries, and reset, even if exit program wasn't functioning well. Now, each of these classes compose the user interface GUI. Database columns is a collection of individual database. So this is a composition of database columns, where this is a aggregation. Likewise, query strings is a composition of the read queries. Moving on, in our design, we have a use case, and this is a simple use case of a user starts a program, they'll log in, and when they log in, they'll have the ability to reset. Suppose they typed in the wrong database name, or they don't want to be in this particular database, they want to be in a different one. Well, the reset button will allow them to go back to the login. And of course, they'll have the ability to just exit, and the exit has a specific purpose, which is to properly end the connection with the database. Now, when they log in, they'll have the ability to use the user interface, and when they have the ability to use the user interface, they'll be able to use the select all, the set conditions, and the set no conditions buttons. Now, you have to choose the select buttons before using the set condition buttons, because the set condition buttons it's based on the select button and what factors are happening within this particular button. But now, once the select button is chosen and the set conditions are set, then the table can be generated. And that's a basic use case of this particular program. Furthermore, the package and the subsystem layering, the application, this is the applications layer, and then its business services, of course, would be to generate the queries that can be used for sociological analysis. And of course, it needs a middleware, and the middleware is the workbench, MySQL workbench, which will be used to connect to the database. And of course, the processes that will be created. Obviously, the start program GUI, the initial process that will be started is the Sdps application. And then this, of course, will cause the login menu process to start. And the login menu will start the access database process. And in this process, we'll start the reset database process and the exit database process, if they are chosen, of course, if one chooses to do this. In addition, when someone successfully accesses the database from the login menu, they then can start the user interface process, which will start the DB column process and the reading queries process. And then in order to implement this, the access database process needs to be connected to MySQL Workbench from remote. And the remote connection is really going to be a localized connection. In theory, it could be a remote connection, but for this project, I'm going to make it a localized connection with the database on my own laptop. And then the user interface will conduct the runnable, because the user interface will be engaging, will be doing read actions. This specific purpose will be doing read actions within the actual database, so it will conduct the runnable. Now the deployment view, obviously you'll use a desktop PC, and a desktop PC will use the Sdps application that will run the sdps.exe, the executable, and then when the Sdps application is working, it will then connect with a JDBC driver that will collect to the legacy MySQL database system. Now my risk management. In my risk management that you can see here, I've created this risk matrix by using the certain probability and the high risk impact and multiply the two numbers in order to create a score. Now, for example, let's say the impact was trivial, and that's an impact rating of 20. And let's say the probability was 20%. Well, that would create a number 5, or hopefully I did that right. No, 4 actually. Which would be a low score because 4 is less than 15. Now, I have several risks in this project. Some of them are losing the client support. I put that as a rare situation, finding testers, because eventually I want to have testers test this project, outside testers, and I think that's a rare occurrence too. Project requirements are very specific, they're very spread out, and I don't expect them to change, so I put that as a rare risk exposure. Faulty project design. This I put as possible because perhaps my design isn't user-friendly, perhaps the design becomes too complicated. And so there's a risk of this my interface potentially being too complicated. So I plan to enact a usability test to reduce this risk. At the same time, insufficient coding skills. I must stick to my work schedule so that if there's a problem that I run into, I can then have the proper time to ameliorate the situation. And of course, managing strict deadlines. Sometimes I have an ability to underestimate how much time I need on the actual project, so I need to properly manage the strict deadlines. And of course, these are my strategies. Insufficient coding skill strategies. I'm going to write the code in Java. If I write it in Java, it's the language I'm most familiar with, and it will allow me to reduce the risk. Strict deadlines, of course, I will follow the UPS schedule to help me stick to the deadlines. Testers, I have testers already found, but I will continue to monitor the strategy in case the testers in case a risk event occurs and the testers are unable for testing. Strict project requirement strategies. I'm going to stick to the requirements are already spelled out for me, and I always have communication with my professor. And I will use this communication as a strategy to keep monitoring if the requirements are okay. The design strategy, I've done a lot of research on it, but I'm going to use the usability test to make sure that the test isn't too complicated. Furthermore, I'm only going to design 4 buttons on this interface so that I minimize the amount of complexity that is required on this interface. And finally, potential loss of client support. I will continue to update my client on the project, and I do not expect to lose their support. They are very enthusiastic on this. And if a new risk emerge, I will record them on a risk occurrence timeframe, classify it, and develop a response to mitigate, monitor, and manage the newly arrived risk. In conclusion, the documentation for this project is complete and implementation will start next fall semester. As stated above, Sdps will only be able to perform read-only results. This is simply a first step before adding more functions to SPDS. But I do want to make it very clear that I don't want SDPS to become SPPS. Because I want SDPS to just do one thing and one thing very well. I want it to be able to do the read-only results well. I want it to be easy to use, and I want it to be learnable, that it can teach someone in SQL basically in 1 hour, some basic fundamentals. But I do think that I could add perhaps write functions in the future. I've also found research, and I've considered perhaps even using natural languages in a search engine so that the natural languages will correlate with the SQL table queries, and together it could even remove the possibility of using buttons entirely. But that's some things I would want to do in the future. And in the future, I'm going to use this test document in order to determine if SDPS is user-friendly. If it passes this test, then the project will be complete. If it does not, I will create an incident report, and then I'll restart another cycle of coding and testing so that it meets all requirements. And then these are my references that I've used for this PPT, this PowerPoint. And in my actual defining the project, I've used a lot more references, but for this purposes, I only use 4 references. And so this is my project. I hope it makes sense. If there's any questions, you can always email me in the class. Thank you for your time, and thank you for listening.